Hi y'all, it's Jess Clary with Jess Clary Auto Repair in Elizabethtown, Kentucky. Today we're working on an 06 Buick Lacrosse. Customer complaint is that the blower motor works intermittently and his air conditioning is not wanting to kick in. When he turns the air conditioner on, the compressor doesn't come on. So we're going to get into this thing as always and do a code scan. This being an older GM, I've got some software here that's more compatible with that, and I've already gotten into it and I'm reading all the HVAC codes. We've got a U1096 lost communication with the instrument panel cluster. This is the HVAC control module has lost communication with it. We have lost communication with the body control module. The HVAC control module has. We have Class 2 data link code, U1000. Class 2 data link lower high code. In the BCM, we have a Class 2 data link high. Lost comm with the climate control panel. So as you can see, I'm just going to toggle through them here. We've got a lot of communication codes. So anytime we have other codes and communication codes, we want to go ahead and try to diagnose the communication codes first and fix those. So I'm going to get out the lab scope. We're going to get hooked to, this is a LIN bus, one wire GM LAN, I should say, Class 2 network. So we're going to get hooked to this. We should see a 7 volt signal on this, so in just one wire, so a little different from CAN that most people are used to here with the later model stuff. So we're going to get the lab scope hooked up here, see what we see. We'll go from there. Let's get started. Okay guys, this is the splice pack for the network here. It has this little comb in it that just connects them all together. We've removed that comb and we're going to de-pin this. We got to pull all the pins out of the back. I've got a schematic that shows the locations they go in. This one's actually been de-pinned before and they're not in the stock locations on a couple of them. So we're going to get these all pulled. I'm not sure if you can see what I'm doing here. I'll try to get a little light on it. I've got a little T-pin. I'm just going to put it in here. There's a little retainer. Pry away from the connector and pull each pin out individual. I'm going to repeat that until I get all these out there. We're going to plug them back into this network. We're going to plug them all back into this comb. And we're going to get a network signal, see what it looks like. This way we can remove individual modules from the network and see if we have a bad network connection, if it makes any difference. Okay, here's the setup. As you can see, I've got my splice connector D-pinned and they're all plugged back into the comb so that I can unplug those one at a time. I have my scope channel 1 on pin 2 of the DLC. That is our purple wire that runs down to that splice connector there. So we're tied into that splice connector. We can de-pin these as we want one at a time. And if you can see my lab scope running here, I'm going to turn the ignition key off and back on. You can see a bunch of network activity. We do have 7 volt square pulses just like we expect. Everything really looks pretty normal on this. So the next step we need to do, since we have heating and air conditioning issues and heating and air conditioning no communication faults, check our communication wire between that splice pack and the back of this module. Okay, so I've got the only wire hooked to this is the network wire from the air conditioning HVAC module. You can see occasionally a little blip here. That is a 7 volt pulse that's coming from the air conditioning module. You can turn the key off and back on and get it to wake back up here. See if we can get, there we go. You can see those communications, little data packets. So we know that has to be coming from the air conditioning module. It's the only thing we're hooked up to. And we know I have verified my wiring between the air conditioning module and the splice pack. So we know that we have good wiring there now. So as far as communication on this, if if we continue to set communication codes, we have to be losing either a power ground to this module, or there's an internal problem with the module, or one of the outputs is pulled down. Now, I got in there and issued a two-way command through the scanner to this module to actuate the blower motor, and it's not functioning. So right now I'm suspecting outputs, but we have verified good communication wiring between the module and the splice pack. So I'm going to check these outputs. We're going to get in here and see why this blower motor is not running, troubleshoot this, repair whatever we need on the output side of this, see if we have any shorts, and we're going to get that to work and see if we have any more communication issues with our module. If we do, then we're going to investigate the powers and grounds to the module. If those check out good, we continue to set communication faults when everything is fixed on the outputs and powers and grounds. It leaves nothing but an intermittently faulty HVAC module. I'm going to run through these connections on this blower resistor. You can just watch the screen and I'll tell you which connections I'm in. Okay, I'm on the plug that plugs directly onto the blower motor resistor. This is a new blower motor resistor that this fellow has put in this car, trying to get his blower to work. All right, right now I am in pin D. Actually, yes, I am in pin D on this blower motor resistor, which should be grounded through the resistor itself to pin A. As you can see, we're at 12 volts. So we clearly have no path to ground through this blower motor module. Like, I'm calling it a blower motor resistor, but it's actually a blower motor module. These are not resistors. So this should ground through the module and be grounded. The module itself is grounded at pin A. So we're going to check pin A and see if the module has a good ground. And it does, good clean ground. So we're going to also check our variable pulse width signal that is coming from the HVAC control module to tell this module to turn on. That is on pin B at the blower control module. Green and black. I'm going to back probe that. This will be your small diameter wire. You can see we have a good pulsed signal here. See if I can get my probe to stay in. Okay. So now on the HVAC control module, I'm going to vary the command, the speed command. There you go. See that pulse width changing as I change the command? I'm turning the command speed down. I'm going to turn it up. You can see the low portion of that signal gets wider as I command it. So this module is commanded to blow when grounded. But we have good signal coming out of our HVAC control unit. That only leaves a couple of wires to check here on this module. We've already checked our ground. We're going to go ahead and check the positive feed. We saw positive voltage on that pin D. That means our motor has good connection through it, and we have a good positive voltage coming from pin E of this blower motor control module. Really, that actually covers it, but we're going to go ahead and check our main feed. We know it's good. We have outputs, but this is coming from battery main fuse battery main 4, fuse 30 amp, and goes into pin C, which is the large diameter red wire on this module. And let me get into that. Okay, you can see we've got good voltage, we've got good ground supplied to the module, we've got a good signal coming out of the HVAC control head. We've got everything this module needs. We've got good connection through the blower motor. The windings are good in the motor, but it's not finding its path to ground through this module. Now, I cleared all those communication codes out. I don't know if this module has shorted one of the outputs coming out of this HVAC control unit and possibly caused those communication codes. But for now, we're not seeing any more communication codes out of this. Okay, so we got one last test to do. We know that this blower control module is bad, but we need to check and see if the motor is operable. So I have a ground run through this light bulb for a current limiter. Both filaments of a halogen bulb. That'd probably carry 8 amps, somewhere in there. We're going to provide a ground to the ground side of this blower motor. We know that it has voltage applied to the positive side, so we're going to provide a ground to this, and we're going to see if the motor turns or if the motor is drawing too much current, and that's what burnt the module. Okay, I've got my amp clamp around it. We've got 7.7 amps. My bulb is fully lit, brightly lit. We have no movement out of that blower motor. So that blower motor is locked up. So this was the original problem. The blower motor is either locked up or shorted and drawing too much current, and it blew his original blower control module. He replaced the module, found the module bad, but didn't catch the motor. He said it did run some after he replaced that, so it must have been locking up or dragging or something. So he replaced that, and it has now burnt up his new module. The communication issues, I suspect, are when it burnt the ground path out of that module. It probably elevated the signal input from the HVAC module, and that probably temporarily interrupted communications, although it is communicating now, and it is still providing a pulse width modulated signal for that blower control module. So as of right now, it's working. Hopefully we didn't do any permanent damage to the HVAC control module. So the diagnosis on the blower portion of this is that it needs a blower motor and a blower control module. Now, as regarding the air conditioner clutch not engaging, I did pull it up on the scanner a moment ago, and in the powertrain control module, I was able to see a data pid for pressure, for refrigerant pressure, and it was very low, and it said disabled on the request for air conditioner enable. So I'm going to go ahead and get a mechanical gauge and stick on this. We're going to verify the pressure of the refrigerant on this system, make sure that there's not a sensor problem. But it looks like that's the third repair that needs to be completed. We need a blower motor, blower control module again, and need to locate the leak and recharge the refrigerant. I'm going to go ahead and check that with a mechanical gauge just to make sure we don't have a sensor problem. But if it turns out to be anything different, I'll include it in this video. But it looks like it's just developed a leak somewhere, which outside the scope of what I do. I don't do air conditioning repairs. Well, guys, thank you for staying with me on this one. It's turned out to be an interesting diagnosis. Kind of started off with a code read and some communication codes. Verified all that system was good. We had good communication to the back of the module. Cleared those codes, and they appear to be staying away right now. So in checking the outputs of that module to verify our communication issue, it led us to the real problem. You know, if I had started at the other end of this, they would have maybe been a bit faster, but you never know which end to start at. I always start with a code read and communication codes first. 9 times out of 10, that's the quickest path. But guys, hope you enjoyed coming along on this one. If you like my content, please like, subscribe, share. If you're local to the Boston, Elizabethtown, Kentucky, Shepherdsville, New Haven, Bardstown, Kentucky area, and you would like to get in touch with me, feel free to do so. If you need some diagnostic work or electronic work done on your car. Thank you so much, you guys. You have a good day. Bye-bye.